Let's the recording start so that I'll again start. Okay, so we are explaining how to simulate using PSPice. Okay, so the different window first, our aim is to place all the parts. Suppose we are designing, going to design a voltage divider. So what all the things I need? I need a voltage source and two resistors. So first I'll take resistance. So I'll click place part, which is in the draw window. I'll take place part. Okay, so this is one option. You can say there are different options which is showing here, which I have, but I need the whole thing. So this is there's option like a binocular window. You can see there's a binocular window just left off. Are you able to see my mouse? Yeah, mouse thing. Yeah, this is a binocular window just left of the. I think there's some difference in coordination of my mouse, the video, and okay. So uh, okay, so place part, get new part. So I'm opening a new window. You're able to see it. There's a window open, place part. This is place new part. Okay, so there are a lot of parts in the bottom. We can see in the window there are a lot of parts. ICs are the resistance or the capacitor, a lot of things, and a lot of components are having their electronic name, their command. These things will be familiar as you will be. Uh, Maybe you have to do some work on your own also, some searching. What is the name of a diode, etc. Or we can search here. So I type R in the place part. In the place part window, I type R. What's happening? So resistance is coming. I'm getting a lot of resistance options of resistances to keep. So this is variable resistance. R bar is variable resistance. This is 1K resistance. So we can change the value. So I keep, now I have to place it. So press the place. You can see right of this. There's a place. Right. What is meaning of placing? I can place the part onto the schematic window. Okay. So I click place. Okay. So what happened? Now my resistance can be placed anywhere. So I place it here. Okay, click it again, it's placed. Now the resistance is placed. Again I can place one more resistance, so I'll place one more resistances. Okay, so I place two resistances. That's it. Now what else I need? I need a voltage source. V sine. Okay, so we need a sine wave. I'm taking sine wave, so I'll take V input or V sine wave something. So you can search it and it will come here. So this is what I wanted, a sine wave, a source. Again I click place. So what I get? Now I can place this sine wave somewhere, right? So I place the sine wave here. Okay, you can place it anywhere. There's no rules regarding you can place anywhere. Okay. Now what I need? Now has sign input sign. Now I will need a ground. I'll just click GND ground. So I got a ground or whatever. So I'll take analog ground. Okay. This is required very important because using the ground, the simulator is able to understand which part of the circuit is my reference voltage. That is which part of the circuit I should refer my all other voltages of the circuit, right? You know what is ground? What is ground? Ground is a reference potential where any other point voltage of any other point is compared to. Okay, so when you click voltage, when you start looking voltage any point, that point voltage difference with that ground potential or zero. You should take it as zero, but there may be some negative potential taken as so it is depends. It's like a reference. Okay, so I need to keep and then do place part. So I go to place again, click the place. Now I'll place the ground. So I place the ground somewhere near the way. Okay, place the ground also. Getting? Now I have three components already placed. Now I need to connect them all. Okay. Okay. So what I'll do now, I can go on placing the ground all the I want. So, but I don't need. So when you click the mouse button, it is again placing all those things. So I just need to click escape. Okay. When I click escape, now I'm not all placing the ground. So these are extra ground. I'll just delete it. Okay. Just click select all of them and click delete. Again, I select all of them. I don't need and I click delete all those things. Same time I can do also. Okay. Now I need to order the circuit. So I need to rotate this thing so that it look nice. So I'll select them and I edit with this option. You remember? It's not, yeah, rotate. The bottom you can see there's option rotate. You're able to see? Again I rotate it so that it is looking okay. Rotate not. There's some error. Okay, selected area would be outside drawing origin. Okay, so it is saying that there is some problem. So I know what the problem is because when it rotates, the resistor will be out of the drawing region. So what I'll do, I'll just take the all the thing, I'll keep it a bit down. I'll select the whole thing, and then what I'll do, I'll keep it a bit down. Okay, that's errors will come naturally, and you have to understand what it is. Okay, now again I go for rotate, again rotate. Okay, now I'm rotate. I have rotated. You can see I rotated my resistance so that it look as per my theoretical understanding. Whatever circuits I had drawn in my notebook or textbooks, and now accordingly I place for this. Okay, now I'll also arrange my V source also, V in source also. Okay, again ground also I'll arrange nicely. Okay, now I need to connect all those things using wire. So I close this place part window. Okay, now I need to connect. So where to connect? I need to use a wire. So there is this option of wire. You can see there's a draw wire option. Are you able to see draw wire option? Yeah, just click it. Now whatever my pen goes, I'm drawing the circuit. Wherever my cursor is going, I can draw the circuit. Okay. So now I'm drawing the line conductor. So it will be like this. Okay, like this. Okay. Are you able to see I've drawn some lines from the V source to the resistor 1, R1, R2, sorry, R2. Again, I connect this R2 and R1. Click. Okay. Just click where you want to start with, and just click where you want to end with. Now the connection is there. Now I want to connect the V negative potential to the ground. So I'll connect like something like this. Okay. Now completed my okay. Now once I have completed this, still there is some wire is still going on. You can see it's still going on. So what I'll do, I'll try just click again escape. Now the connection, the selection of my wire is gone. Now it is gone. Now I need to delete this extra thing. So you just select it and delete it. Okay. Okay. So so this is my circuit. Now circuit is looking big. So I don't need the magnifier. I'll just okay. Now is it visible, right? Now things are visible. Fine. Now circuit is bigger. Now I have placed my whole hardware part of the circuit. Now I should tell the simulator what are the values of the V1 voltage I'm going to give to the circuit. Okay. I can double click any of the component and change the parameters. For example, R2 I can double click and change the value of R2. The different options of putting the value of R2. Okay. There's some error. Okay, here R2, I am double clicking R2. Now the value of R2 I think is not visible for you. So so now I think it will be visible. These are the parameters of R2. You can see the value. There is something called value 1K. I can change the value to 10K. I'm putting in 10K. Okay. Now I just put save attribute top right, then bottom right. Okay. Now the value is changed to 10K. Now again I click on the R1, double click it. Again the parameters are opening, and the value, that's the option value. I'll change the value to maybe 20K. So 20K. Okay. Again save the attribute and press OK. Ready? So we have 10K and 20K resistance. Now V1. Now you go for source. Double click on the source. So what are the parameter name, value name? This is design name. This is V1. And then you have to give DC. What is the DC voltage you expect from the sine wave? Don't need any DC, so I put 0. Okay. Again, that is save attribute. Again AC. What is the AC voltage you expect from here? I need only 5 volt. So I press 5 and save. And V off. I don't need V off is 0 volt. There are a lot of parameters. If you want to see what each parameters correspond to, you need to see the data sheet of this model. Okay. So you just leave it. Whatever you don't know, you just put it 0. That's it. Okay. Now what is V amplitude? V amplitude, AC sine wave as an amplitude. So amplitude should be 5 volt because my maximum voltage I expect is 5 volt. So I give 5 volt. We can give 5 V also, 5 volt. That is, everything is possible. Okay. Now, what is frequency? Whenever there is a AC sine wave, you have a amplitude as well as frequency. So, what is the frequency you are checking? I think I'll take a frequency of 1 kilohertz. So, I'll write 1K. I can write 1K, or I can directly write like this, 1000. Okay, whatever, it's up to you. So, I'll write standard 1K. Okay, 1K, 1M, 1G. Okay, all those things. Okay. Now I think it's done. I think again I'll try again. DC is 0, AC voltage 5, V of 0, V amplitude 5, V frequency is 5. Maybe there's a phase also. No, other things are TD and all those things. TD is time delay. These all things are not recorded here. You can put as 0. For advanced simulation you need 0. So I save thing and press OK. Okay. Now, now our circuit and specifications are complete. R1, R2 values are given, V1 amplitude, everything is given. Now the next part is now the uh, next part is I am starting my simulation. First of all, what is the thing? Whatever you have done, you have to save it. Whatever you have done, you have to save it. There is file, save as. Okay, so I'm saving it somewhere. I'm saving uh, my circuit name as analog analog 1. Okay, analog 1. Okay, you can see the save as type is .sch. It will be same as .schematic sch. Okay, so now I'll save it. Your first duty is to save it. Okay, now it is saved. Now second thing is, after saving it, you have to start analysis. You have to go to analysis. What are the things in the analysis? First, electrical rule check. If you click it, it'll check whatever error is there and it'll tell you if there any error is there. It'll tell you. Okay, there's a connection, lacking connection. Okay. Next is create netlist. What is create netlist? This is what I told you before simulating. Before simulating, the simulator needs to create a file which is called netlist file. What is that file? Whatever our circuit is there, it converts the circuit into a its own recognizable schematic, or the simulator will recognize its own variables, uh, its own model parameters, resistant capacity, etc. So it creates its own netlist. It's like a hardware thing, hardware netlist. Okay, it has its own file. You can imagine it's a matrix where all these components of a circuit, it puts its own memory, whatever it understands. According to its understanding, it converts into a hardware file. So that is important. So I create a netlist. Here also, if there is error, it will tell there is a netlist error. If I have extra wire, it says that there is a extra wire which it is not able to understand. So netlist failed. So I'll again go to circuit and I'll check it and I'll make it correct. Okay, then I again create a netlist. Okay, now I have to do setup. There is a fourth option, setup. What is setup? You have to set up the simulation. There are different kinds of simulation. We already discussed some kind of, like, initially we were drawing a lot of graphs. One is time with respect to time, we call transient analysis. Another was output input characteristics, V out versus V in, and there is I versus V, IV characteristics. Okay, the different types of simulation. There are frequency analysis. Okay, there are noise analysis. So we'll see what all things are. So we'll just click it. So there's another window open. Setup. This is different analysis possible in the PSPice. Okay, the different. Although I'll not explain everything. The different high advanced simulations also. Okay, like Monte Carlo analysis, noise analysis. Okay, AC sweep. Sweep means we are varying voltage from 0 to some value. DC sweep. DC also we can vary from and check what is the function or behavior of a circuit. So what we are going for, shape transient analysis. We already discussed what is transient analysis. Transient means with respect to time. So we are concerned about the shape of the waveform with respect to time. Okay, from 0 to a point time, we are interested what is my sine wave output, or what is how this wave is behaving, etc. So that is called transient. So when we click it, then we have to go inside the transient to set parameters. So another window is opening. Here we have to tell the simulator, okay, where is my simulation starting? 0 nanosecond. Now it is 0 nanosecond, and final time is 1000 nanosecond. I'm getting, everyone is with me? Just give this, whatever record you just give. Starting time is 0 nanosecond, final time is 1000 nanosecond. Okay, that's it. That is required. Whatever is required you give and press OK. Okay, so my simulator is ready to simulate from 0 to 100,000 nanosecond. That is 1000 nanosecond, 1 microsecond. Okay, now it is done. I'll close it. Now again, now I can directly simulate. So before simulation, what you need? You need to tell the simulator which waveform or which parameter you are interested in. What is the meaning of what is the meaning? You have to tell I am interested in the voltage at this point. I am interested in the current flowing across circuit, etc., etc. You getting? So we are always telling the simulator what parameter we want to see in the circuit. Okay, so so there is another option in the top right of the simulator. You can see there are some things in the top right. You can see this is a scope. What is this? This is like a voltmeter or meter which you might have used in your lab, and you just click it. Now you can keep the voltmeter anywhere in your circuit so that you can measure the voltage at that point. Or simulator will show the voltage waveform from 0 to 1000 nanosecond at that point. So I click it here so that I can see the input voltage. You getting? Now click with the input V1 so that I can see what is the variation I'm getting in the input. Now again, if I put here, is it okay? No, it's not okay because both are same point. So what I'll do? Again, I put in the middle point, voltage divider R1. Across R1, I'm interested what is the voltage across R1. Okay. Now again, I can keep it going on, keeping any time, anywhere, but it's already it's called node. It should only keep in nodes. I should keep this only in nodes. But this I already have kept. So again, I press escape button. It is gone. Again, I press delete. After selecting, I delete. Okay. Now you can see circuit. We can this circuit. It is this is a circuit. So what have we are done? Okay. So what all things we have done here? First, we have put whatever components in the circuit. Then we have connected the wires, electrical conductors, and we have put a ground. Then we have given values to our different resistance and voltage sources. What is the maximum peak voltage in the waveform? What is the ground? What is the frequency, etc. Then what we have given? Then we have gone saved it in a file name, analog one, whatever. Then we create electrical rule check. We have done electrical rule check. There's no problem. Everything we are satisfying. There is no misconnection. There's no uh, any problems. Okay, then create netlist. Then we create a netlist. Then the circuit is put into the memory of the simulator with its own library. Okay, so it recognizes everything and it has a model for everything. So it makes, okay, I have created my netlist. Then we go for setup. In setup, we told the simulator we are interested in transient analysis, and transient analysis the variation of the voltage or a signal with respect to time. Again, we click inside the transient analysis. We set it for 0 nanosecond to 1000 nanosecond is what we want. We are interested in the time. Okay, then we press OK. Then we close it. It's done. Then again we go for simulation. Then we go for simulate. Now what we done before going to simulation, we kept two scope or voltmeter. One is the input voltage, another is in the across R1. Okay, so these are the places which we are interested to see the waveform of our uh, signal, whatever signal, this voltage. So now this is two option, voltage and current. So I place voltage only. Okay, although we'll after this basic we'll do a bit of better advanced thing. Now just click the simulate. Now there's option, I don't think you'll be seeing it. There is another option, simulate, that is also in the analysis window. Okay, simulate, right? So just click it. Now the simulation started. Now the simulator is calculating the now a window is opening. Okay, so I don't think anyone is able to see this completely, so I'll make it smaller for you. Okay, now is it visible? The simulator window is automatically opened. Oh, what is happening here? I given what we expected sine wave. Okay, is it visible, right? There are two red line, one red line and one green line. So so I'll just brief you what is happening. This is our circuit. There's a resistor divider, two resistances, and I given AC input voltage. But when it is running, and I already told the simulator I'm interested in the voltage across this point and this point. One is input, so that I can see my input, and I'm interested in voltage across R1. That is, I kept it here. Okay. So similarly, to calculate the voltage V across the input and the R1 with respect to the ground potential. But you can see the simulator is giving what I'm not expecting. It is like a shock to me. What is happening? I wanted a sine wave, but I'm getting something else. So what is happening? You're able to see very clearly, right? So you can see where we are starting from 0 nanosecond, and it is going to point to 0 nanosecond, then point to microsecond, 0.4 microsecond, till it is simulating till 1 microsecond. 1 microsecond. That is 1000 nanosecond. That is what we expected. And it is saying that it is a straight line. What is happening? Who can tell me? What is the problem? What is happening? Is it some mistake? Is the simulator not working, or if I am doing any mistake? Yeah, this is a problem. You have to think very fast and tell me. Yes. Again, I just want to repeat what we have done. We have just made a circuit of a voltage divider, and we are given a sine wave, AC sine wave with a peak voltage 5. Okay. And we are checking voltage across the input, which we have already given, and voltage across R1. We can see the voltage across this VR1. You can see VR1 is green, and V input V across V1 for the input source is red, and we are getting a something contrary to our expectation. This is getting a straight line. So what is the problem, and what are we going wrong? Yeah, I want everyone to think and tell me what is happening. Okay, if you want a circuit, I'll show the circuit again so that you can again think if there is any problem with the circuit. Yeah, this is our circuit. Okay, a simple voltage divider without any complication, but we are getting a unexplicable result. And our result is, this is our result. I'll just keep both parallelly so that we can have a good look at it. Okay, this is our circuit with this is input output of a siphon. Okay. Oh yes, I need comments from you. Yeah, the voltage which we provided DC is 5 volts and frequency is 1K, but it is a DC. This is showing a straight line. But as it is a DC, can I ask commenting that this is okay? This is not DC actually. We can see we are given a AC only. V1 is AC. I can just double click the V1 and you can see that it is 0 DC 0. We are given even the V sign has also a component of DC, but we still have given it 0. You can see the DC component of our AC is 0. AC component is 5 volt. V off is 0. V amplitude is 5 volt. That is maximum amplitude. Okay. Frequency is 1K. These are the parameters. Okay. Fine. So just I'm satisfied with that thing. And although you can say it's not AC or DC also in the output waveform, you can see it's not a kind of AC or DC or whatever. That is up to you to find out what is happening. Yeah. Anyone? I want comments. No, the convenience point is we have given DC as input. No, I have given AC, and but I'm not getting what I want. Any other comments? I want you to think. No, when you are using a simulator, you have to think very carefully. Else you will conclude that yeah, simulator is wrong. Or what nonsense is this? Or am I wrong? I don't know anything. I leave. But you can see the scale. What we are saying, voltage scale of the output. So you can see the scale of the output. Just see the scale. Maximum voltage we are reaching is 40 millivolt, and time we are reaching is 1 microsecond. Yeah, another comment. Yes, yes, yes. That is what. Yeah, Mrutyunjay is saying. Yeah, this may be right or wrong. We don't know. But what we are saying is a small part of the output window. Yeah, it can be a possibility. Small part of Wi-Fi. Yeah, that is a one option. That means like human beings, we think that we know everything, but we are only seeing very small of the universe and also something like that. So, so why it happened? Am I simulator not uh, adaptable to what I need? So why it happened? Can anyone tell me? Yeah, actually, the thing is that is the point. We are seeing something which is very small. How can I conclude that? Because I can see the voltage is only 40 millivolt at the top, and the time window is 1 microsecond. So you should know there are two things we have done. Just looking to the past, what are the two things we have done? One thing is we have gone to the analysis part where we have set up some analysis, and that setups we are given a transient analysis where my simulation window, I told it I had to simulate from 0 to 1000 nanosecond. Getting? So simulator is sure it only need to show me the simulation from 0 to 1000 nanosecond. Getting? So it is showing, now it is showing only what I need. You can see 1 micro, it is showing till 1 microsecond. That is nothing but 1 nanosecond. Sorry, 1000 nanosecond. So I am asked something, he is showing exactly that thing. Getting? But at the same time, it should very important that the frequency which I set it in V1, the frequency which I set it is 1K. Okay, so 1K means what is the frequency? 1K, you should know there are 1000 cycles in 1 second. That means the waveform is very big. That means 1K in 1 second. Therefore, one cycle it need 1 millisecond, right? Am I right? 1K, 1K in 1 second. 1K frequency means in one, for one cycle it needs 1 by 1K or 1 millisecond to complete. But we are here looking how much? We are looking, देखो 1000 nanosecond check, 1 microsecond ही check कर रहे हैं. That means this is a very small part, that is around so you just calculate in your notebook we are what part of the sine wave we are seeing. Our sine wave should be complete cycle के लिए कितना चाहिए? How much? 1 by 1K, that is 1 millisecond, right? We need to see 1 millisecond to see at least one cycle of the sine wave. But we are told him to only tell 1 microsecond. We are only told the simulator tell, show me 1000 nanosecond. Okay, so that is our part. So here the solution is we can click and tell the simulator show me more, or I can tell that reduce my frequency, whatever. Oh, sorry, increase my frequency. Increase the frequency means my time period will reduce, so I can see the full waveform in 0 to 1 microsecond. Like if I keep 1 gigahertz, I have very high frequency. So from small window, I can see different waveforms. So here, what I'm saying is, I'll go to simulator. I don't want to change the input, so I'll just want to see the full waveform. So what I'll do, I'll go to the simulator. So let me close this thing. This everything is fine. This whole things are fine. Now I go to the simulation analysis. Now I'll tell the simulator, give me. I need to see more time. So this is only 1000 nanoseconds. So I'll tell it, show me 1000 microsecond. That will be too much. So uh, yeah, tell me 1000 microsecond. Show me 1100 microsecond. No, let it 1000 microsecond. Fine. Let's see. So I changed the end time of simulation to 1000 microsecond. Now I click OK. Save. Again I'll do the same procedure. Again I go for simulating. Yes. Now I have got another output. Yes. Sorry. Now you can see, now the waveform is clear. Now I can see the full waveform. You can see how much I'm simulating. Now you can see it's 1 millisecond. Yes, I'm simulating till 1000 microsecond. That means I'm simulating 1 millisecond. Now one complete or cycle I'm able to see. Getting? Now you can see what is the voltages here. The green is voltage across R1. That is divided voltage divider. Okay, and red is the V1 voltage equals the source. Okay, so from here I can see voltage at every point. Now I'm interested in seeing the current also. So what I'll do, I'll again place the current scope, that is, so that this scope give me current in the circuit. So I click it and click. Okay, so I should keep my current somewhere. So I, now I will give me the current also. Okay, now along with voltage at these 2 points, I need the current also. But you can see the scale may not match. Let's see. There can be some problem, but let's see. Why the problem I'm expecting? Because the current may be in million micro, voltage may be in voltage. Okay, not in micro. So there may be some inconsistencies in if they are plotting in single graph. Let's see. Again, I, because of the new thing command and keep, I had to create the netlist. Again, I need to simulate again. Let's see. Yes. So who can explain this thing? Now we can say V green is VR1, red is a V source V1, and the blue is VIR2 minus IR2. So what is the meaning of the circuit? So I'll minimize the okay. So this is my window waveform. You can see if I don't know you're able to, you can see the green, sorry, not the green, the blue thing. It is practically zero. There's no change in this. Why it is happening? You can see that blue line is not showing any magnitude because it is in milli or microsecond, but my voltage is in 1 to 5 volt. Magnitude wise, you can see it's negligible. So this is not a way of comparing voltage and current in the same waveform. So either we need to make a new waveform, or we just need to remove the we just need to remove the voltages from this. So I select the voltages and delete it, so that I can see the current alone, so that I can see the magnitude of the current. Okay, again I save it, again analysis, again I create netlist, a new netlist, then I simulate. That's it. Now you can see the current across the circuit. So this is the current. Now you can see the current. What is the value of the current? You can see it is starting from 0, it is 200 microsecond in the top, and minus 200 microsecond in the bottom. And definitely, as we expect, this is a sine wave. Definitely input is sine wave, so definitely current should also be a sine wave. Okay, so this is, we got the current. So what is the problem we face? When we plotted the voltage and current in the same graph, we know current is negligible. It is few micro or milli, but voltage is big. So we don't see any effect of current in the waveform. Now, now we will change the mm, now another one option. I'll tell you one more option. Whenever in any circuit you want to see the DC voltages, you need to click. There's a point here. You can see the right, top right. There's a V and I. Just click it. It shows the instantaneous average value of each point. Here I am giving AC voltage, so the AC average or instantaneous value is 0, or the RMS value is 0. You can say average value is 0, so it's showing 0. Okay. In current also I'll have the same thing. If I click the current, I can see the current is also showing at each point of the circuit. You can see here it's a AC waveform, so you cannot expect anything other than 0. But when you're other circuits like diode circuit, transistor circuits, or DC voltage circuits, it will be very good, so that we can get the average voltage of our circuit. Okay, so this is the option which shows me instantaneous current. It is in top right, and when I click again, it don't show it. Okay, now I want to make the circuit a bit complicated. Okay, so now I want to keep a diode in the circuit. So what I will do, I need to keep a diode. So first I want to keep a diode at the top position. So I want to edit it. Okay, so I'll keep a diode here. So first I'll delete the line. I'll selected the line, so I delete the line. Okay, now again I go to place part. Place part is also draw maybe a place part. I don't know why place part is coming. Usually place part should show the everything. Okay, so I go get new part. Yeah, this is the bottom part. I get new part. Okay, Control G. Either you can plus Control G, or you can go here, or you can go here also. There is an option in the window at the top. You can see no binocular thing, draw block or get new part, binocular thing. Okay, you click the, it shows the same window. Now I want the diode. So what I'll do, I'll type diode in the part diode. Okay, so it is showing a lot of diodes. These are different diodes. The IN401. These are different companies of diodes, which you are right now you may not be familiar, but as you goes on the course you will be familiar. So this is one diode IN4002, which is industrial standard. So I'm using that diode and I'm placing it. Okay, click place. Then just close this window. Now diode is in my hand. Now I'm placing it here. That is done. Now again the diode is coming. Again and I click it. I more and more diode will place. So what I'll do? Just click escape. Now again I select all these diodes and delete it. Okay, so it's gone. Now I need to place wire. Now I click the wire. Again this is connected. Again click it and connect the end from this connect. Okay, now it's done. Now I have completed my circuit. I just kept a diode across this voltage input. Okay, so now this is my new circuit. Now what I'll do again, I have to save it. First of all, some changes has made, so I'll save it. Then what? Analysis, create electrical rule check. Yes, then create netlist so that the simulator has the memory of the hardware components from its library. Then what? Okay. And instead of 1000 micro, I can write 1 milli. Getting 1 millisecond. That is also fine. Okay. So let me simulate for 10 milliseconds so that I have multiple waveforms. So I'll simulate 5 milliseconds. Okay, so that I have 5 waveforms. Okay, okay. Then I close this. Now again I have to go for simulate. Now you should know I'm calculating the current. Okay, so this is my output window. It is showing current. You can see the current. It has reduced. Can anyone tell me last time when I simulated the current maximum voltage of the current was, sorry, maximum magnitude of the current was plus 200 microampere and minus 200 microampere. Right now it is minus, there is no negative because it is a diode. I kept a diode, so the negative waves are cut, but positive it is come down. Can anyone tell me why? Okay, there's some question in between. I'm not able to read the chat parallelly. So how can we show VI characteristics in same one? Yeah, no, same graph we cannot show the VI characteristics. There's a question here from Kanaya. How can we show the VI characteristics in the same one? We can show the VI characteristics also. We can show any parameter versus any parameter graph. Not only any parameter with any parameter like voltage, current, or whatever. We can also plot the numerical equations. For example, we are calculating the log of one variable, so we can calculate plot log v versus I, log I versus v, exponential I versus v, exponential v versus log I. So all those things are possible. We'll discuss one by one. Everything is possible. This is also used in research purpose. Also people are doing a lot of mathematical analysis, so you don't need to worry, everything we can do it. So my question is, yes, Saurabh has answered. Yeah, my peak of my current was to 200 microampere. Right now it have reduced. Now because this is a real diode. Now whenever you use industrial standard diode IN4002, it is an industrial standard diode, it has some resistance. So because of that my current has reduced. Okay. Now let me compare the input and output waveform. So I close this window. Again I'll go to my circuit. Now I'll change the current. I'll delete the current thing. I'll delete. Now I need the voltage. Now I keep the voltage. Voltage at this point I'm interested in. Not this point. This is input point I'm interested, and now 3 voltages I'm interested, right? What are 3 voltages I'm interested in? Yeah. One is input voltage. I'm always interested what is my input, and I'm always interested what is the output of my diode. Okay. And third I'm interested is what is the resistor divider voltage. That is voltage across R1. Okay. Again, save it. Go for save. Again, go to analysis. Create netlist. Although it's not required, but still, again simulate. Now current has हटा दिया है, current का हटा दिया है. I'm just seeing 3 voltage. Now we can see the uh, waveform. There are 3 voltages here. Okay. So what is, so you can see V. Green is voltage across R2. Red is voltage across D1. Not voltage across D1, voltage before D1. And blue is voltage across R2. So this is my output waveform. You can see 3. Red is input. Okay. Um, yeah. Blue is voltage output of the diode. You can see it is slightly reduced. Voltage is slightly reduced because diode drop. Diode, practical diode or real diode has a small voltage drop 0.7. If you measure this difference between red and blue, it will get it. You'll get the 0.7 voltage drop. This also we can do in the simulator. We can get the difference of two voltages and plot. Is also possible. And you can see the difference between the green and the blue. Why this happens? Because of the resistance divider, voltage divider, R1 and R2. Okay, and this is a half wave rectifier. So only half wave is passing across the output, that is green and blue, and red is input. Okay, so it is, that's it. So this is my output waveform. I'm showing 5 windows. If I can show one, that is I can reduce my simulation window. Okay, now now this is done. I think everything is clear. So things are very simple in schematic. Whatever circuit, you just need to keep it in the schematic. Okay. Now suppose you have some complicated circuit like a capacitor. You have to add one more capacitor. Suppose I have, was a capacitor. Again, place the new part. I just type C. I get the capacitor. Okay. So this capacitor, I just need to place it. Okay. So I am keeping it somewhere here. Okay. Then I delete the wire so that I can keep the capacitor here. So capacitor, I click it and Control R, it rotates. Okay. So it is rotated. Now I can directly connect it. Again, I connect with the, okay. So what I'm trying to do, I'm not having any plan, any circuit. So let us try clamper. Some type of clamper will try to make. Uh, I think it's time. So I think I will give you the link of the PSPice so that you can download. You can try the simple circuits, and you can also next class for advanced things like as I was talking, how can we plot VI characteristic, IV, and all those complicated things. This is also possible, and mathematical expressions of the parameters are also possible. That we'll discuss or we can explore as time goes on. And this is important because as we go into transistors, it is not easy to analyze everything because we are starting, we can make mistakes. So it's very important that whatever we simulate manually or in our mind, we should confirm with a simulator. Oh yeah, whatever I think my analysis is right. If we are not getting whatever we expect, we should again think, is there any problem with the way I have connected the circuit, or is there any conceptual understanding which I have not got it? Okay, so this is very important. But don't use simulator as a blind tool. Don't blindly put all the circuits and see what is output and just submit it in the exam or assignment. No, first you have to do your own homework. Your own homework is you should do the things on your mind, then go for simulation to confirm whether your analysis is right. Okay, don't blindly go to simulator. First confirm, first you do on your own, then confirm using simulator. Okay, that is the only way you are going to learn your learn the circuit design skills or your analysis skills. All your basic circuit analysis things also you can keep it here. Different voltage also you can keep it here. All those different scenarios, even there are even digital logic gates, ICs are also there. Although you are not familiar, you can next time you'll be learning digital electronics. So there are a lot of electronics devices are there. Okay, when memories are there, small. latches, flip flops, a lot of things. So it's very comprehensive, and a lot of ICs, commonly available ICs are also there. For example, 741 ICs, very famous op amp IC. Sorry, this is not 741. So op amp. Yes, this is op amp. So operational amplifier. We have this. This is one of the main part of analog. We were learning last module. This is op amp. I think it's visible. So this is the operational amplifier. You can do a lot of amplifiers, filters, lot of mathematical operations, and a lot of things can be done using this simple op amp. Okay, all those practical signal processing analog circuits consist of op amp. Even amplifier, even loudspeaker, your all those analog, whatever analog you can think, you can design using op amp. Okay, so we'll also discuss in the last module. So okay, so this thing we are session we are ending here, and I'll give you the link in Google Classroom, and you can just try to download it and play with the different components. And you may find some problem because starting you may feel why this is not working. So you have to explore. Some diode models may not work properly. Okay, some transistors models. So you have to explore, and I can also I have tried something, so I know something is working, something is not working. So okay, so this is a small version. This size of the simulator is very small. I think it's 30 or so, less than that. But real simulators in real companies or even research, we need simulators of very, even cost of simulators are coming in crores, not lakhs, crores. Why? Because licenses are very costly. You know, this people provide licenses, a particular number of licenses, maybe 10, 20, 30, etc. So these licenses are very costly. So these some softwares are very GB. They have a lot of libraries, a lot of latest fabrication things. Okay, suppose you want to make a chip, you should use the standard library which is available by given you by the companies, because using that devices only you will be able to fabricate your own chip, your own ICs, your own devices, all those things. Okay, only chip is the devices you can make your own, not a problem. Okay, using discrete components, you don't need uh, nano level components for this. Okay, so simulation is very important. Okay, even in your resume it is a very good. I know this PSPice simulator is a very good thing. And even interviews also they will ask how many simulators have you worked in. So this initially you can improve your circuit analysis. You can see RC constant, how the waveform of capacitor is changing, how inductor works, how resistance is connected to capacitance to make a timer waveform, RC time, etc. etc. A lot of things can be done. So you explore, and I will put the link of this thing, or I can, if I try to put the full simulator, it's possible. I'll try, but there are some restrictions in the Gmail, and because it's an executable file, so it may not be able to send too many. So I'll try to do whatever is possible. Okay, that's it. Any questions you can ask? Yeah, you can put your roll number. Yeah. Okay, you can stop recording as well.